Welcome everyone to a closer look at Intel's SGX extension. People might have noticed here one vendor of PC BluRay software player here has recently updated frequently asked questions update here. Customers want, why can't I play Ultra HD aka 4K BluRay movies on my latest Intel CPU 4th gen or above? That doesn't support Intel's SGX feature. Also, yeah, the answer already in the question, right? Because it doesn't support Intel's SGX feature anymore. Why are those Ultra HD BluRay discs no longer playable after related Intel drivers, Windows OS were updated and so on? So yeah, Intel Software Guard Extension Intel SGX, closer look in a minute. Also, recurring theme, we had this here again. x86 complex instructions architecture, proprietary to Intel and AMD, and so complex 2021, 2022 Intel, yeah, too complex for Intel, they can't even ship. Well, not only designed to work them properly as previously TSX transactional synchronization extension, but now also SGX. So recurring theme, x86 too complex, especially x86 and especially all those even more complex last decade extensions too complex for the creator, deprecated and stuff. Removed, so yeah, support removed at some point on the new versions of Intel drivers, utility programs and firmware and microcode. So I think this means even if you, so first of all, Intel again, right? So Intel did it before, in my opinion, huge shout out here also, not only right to repair, but also how can vendors get away? They sell AAA, not cheap, like state of the art or like highest tier CPUs for potentially thousands of dollars, certainly hundreds, if not thousands of dollars. And they just take features away from you, right? There's like, YOLO, whatever. And shouldn't there be some warranty of if you sell, like if Intel sells you and me and us, defective, insecure. So this is a secure extension that is proven insecure, and now they deprecate it and remove it, similar to the transactional synchronization extension. Closer look in a minute. And in my opinion, this is not right. This is not okay that Intel recurrently sells stuff that doesn't work as advertised, as in the TSX transactional synchronization extension that even was announced, it was shipped, and then Intel even removed it very early on as not working correctly and stable as intended. Anyway, but we get ahead. So in my opinion, so not only does Intel not support this in new CPUs because they're too difficult, we gave up on this, it's too insecure, our secure stuff is too insecure, we don't even bother keep trying. But they also remove this from their drivers and software. So if you update, according to this FAQ, if you update your software on Windows, then you lose these features, you lose what you potentially have brought this for, namely using 4K Ultra HD BluRay stuff and similar features. The TSX stuff is more useful, more to that in a minute. And so yeah, that's the state. So for users who want, who are on, so also yeah, the vendor's recommendation, right? So removal of the SGX feature and its compatibility with the latest Windows OS and drivers that causes a substantial challenge for Cyberlink to continue supporting Ultra HD BluRay. Also yeah, 2022. It is a challenge, a substantial challenge for PC vendor software to continue supporting latest and greatest consumer features, right? And the crazy thing is we can live stream or stream content, but you can't buy it on optical discs, or you can buy it on optical discs, but then not play it on your PC, only on some consoles. A little bit strange world, like so latest and greatest Ultra HD stuff you can't play on your PC because there's security and the lack thereof. Anyway, users who use an older compatible platform, by the way, where did they, keep Ultra HD BluRay compatibility on the PC And with Power DVD, they suggest to continue using the, so yeah, recommendation, just use the freaking old stuff and don't upgrade the software. Amazing. So state of Windows and PC and Intel, yeah, just keep using the old stuff. I mean, you save money. I mean, not that you can buy the latest and greatest, but hey, you save money and yeah, and security and stuff, right? It's also crazy. So I think for security, they are probably from the BluRay implementers specification and certification stuff probably not allowed to implement it in a way that, like, basically I think there are probably hardware requirements of keeping this secure, which is probably why they can't legally for their BluRay license and implementers and contract stuff keep supporting this on non-SGX platform. So what is it stuff? This stuff is actually not too, well, if it would work, right? Also, Intel still advertises this stuff, right? Take control of protecting your data, aka accept it's insecure and they don't support it anymore. Also, enhance your code, data protection and solutions and services, and develop secure stuff for our deprecated stuff. It's like 3rd gen Intel Xeon scalable processors with Intel SGX, exactly, yeah, deprecated and stuff, yeah. But PC rendered in Intel, what should I say? So what is this? Is this stuff? This stuff is an extension of the already overly complex x86 instruction set, which already had a fair amount of extensions, starting in 1978 with the 86. We only 86. We only get very quickly over that, right? So they extended this with protected mode with the 286. We could still keep using that majorly since the 386. They added the system management mode, aka ring -1 or so. Later added the FPU, also not really an extension, it's like, yeah, whatever, but then they added MMX, so these are the other extensions, right, multimedia extensions. AMD added 3D Now, Intel then added SSE, professional 3D Now here, SSE2, these are all those extensions that were not part of the original 86 or 386 instruction set, but these are simple extensions, right, of vector, single instruction, multiple data, multiplying RGBA values or 3D vectors. And basically, instead of coding that with old-fashioned x86 instructions of multiply and so on, having one instruction to multiply multiple values, and I basically read 64 or 128 or 256 and or AVX 512 bits at a time, multiply, accumulate, and shuffle and similar stuff. So other extensions then, of course, after all the SSE stuff, also AVX, of course, and then other stuff like F16 for half precision, single and floating point precision, extended operations from AMD, FMA4 fused multiply add, light-wide profiling, such stuff, and then SMX, safer mode extensions needed to facilitate trust decisions of Intel's trusted execution technology. Then even Hool instructions of not having crypto stuff, having hundreds of instructions implementing AES, encryption scheme in hardware. Other stuff like trading bit manipulation, also, yeah, relatively useful stuff only in 2012. Bit manipulation, because, yeah, 2013, right, bit manipulation, not a thing of the 70s and 80s, but yeah, we added that in 2013, at least AMD added, and Intel only in 2013. So making x86 even more complex with the most complex instructions, right? Later they also added of course AVX 512, but also SGX in 2015. So this stuff is not even that old, right? Only 7 years later, it's like, yeah, YOLO, we fucked up. We don't even support this stuff, deprecated, and yeah, YOLO, whatever. And the other stuff was, of course, TSX, or here was that, TSX 2013 Transactional Synchronization Extension, another extension that Intel had problems getting to support stable initially and to this date. So what is all this stuff? As mentioned, and I will make more dedicated low-level programming 101 videos this year. So you probably want to share, like, and subscribe for this stuff. But simply speaking, CPUs, x86, Motorola 68K, PowerPC, RISC-V, they do stuff like load, store, add, subtract, multiply, divide, and the stuff for integer and floating point, aka fractional numbers, and compare and jump, and that's more or less it. And so these extensions are relatively complex stuff of adding really complex mechanisms to CPU state, namely in the Intel SGX stuff, security-related instructions that built into those CPUs define private regions of memory called enclaves, whose content are then protected and and should be unable, but are not really, to be either read or saved by any process outside of this enclave, including processes running on a higher privilege level, aka the kernel. So the kernel should not be able to read and save the content of your 4K UHD BluRay player. So this involves apparently encryption by the CPU. So this is modifying the whole load store from memory, from portions of the memory, and the enclave is decrypted on the fly. So this bits, even if you would for your fancy DRM, digital rights management, for your BluRay encryption keys, to be snooped with probing that on the memory bus, for example, or just patching the kernel, but even physically, monitoring the memory is not enough, or should not be enough, for stealing your precious video content encryption keys. So the enclave memory is supposed to be encrypted, decrypted on the fly within the CPU itself, even then only for code and data running from within the enclave itself. And this processor should protect this code from being spied upon or examined by other code, aka in this super personal data and life dangerous task of playing video files, right? And crazy that we talk about such memory protection in the context of just freaking playing your physical optical spinning Blu-ray disc, but crazy times, right? DRM. So the thing is, as per usual, it sounded good on paper until also the problem also with Intel's vendor extension, right? They just YOLO something into the CPU and then it's like, hey, it's super top-notch secure, right? I think even I read when this was new 7 years ago, I think I read from friends and stuff that you had to sign an NDA, right? Correct me if I'm wrong, but I remember the stuff was not, the specification was not, so not the implementation details, but the specification for you to use it on your CPU, on your hobby OS, like Linux. As far as I remember, were not open and you had to sign an NDA or something to just use it, but correct me if I'm wrong, this is just from memory. Anyway, so multiple attacks, prime and probe attack in 2017, Austria's Graz University of Technology, Spectre-like attack, LES group of College London show proof of concept that Spectre, speculation, execution, security vulnerability can be adapted to attack the secure enclave. Enclave attack 2019, again Austria's Graz University of Technology, published findings. Microscope replay attack of proliferation of side channel attacks plugging modern computer architectures. Measure slight non-deterministic variations of the execution of some code. So the attacker need many, possibly tens of thousands of measurements to learn secrets. However, the microscopic attacker allows malicious OS to replay code an arbitrary number of times, regardless of the program's actual structure, enabling dozens of side channel attacks. And you should also not forget, I mean, 10,000 of replays is not even too much, right? If you are a professional Blu-ray pirateer and want to find the Blu-ray keys, then of course you could just and stuff, but if you are a top-notch researcher and security analyst and stuff, you could just replay this code some 10,000 times. Probably even if after you did the research and like of years of research and stuff, eventually it could only take minutes potentially to rerun this code on a latest multi-gigahertz CPU, of course, some 10,000 times. Plundervault researchers were able to inject timing-specific faults into execution with an enclave resulting in leakage of information and LVI of load value injection, data into the program aiming to replace the value load from memory, which used to, and so on, SGX, vulnerably extended the speculative execution code on cache, leaking content of the enclave. This allows an attacker to access private CPU keys. And it's like, yeah. And after all of this, right, and that is a crazy thing, right? 2022, we are still in a state when Intel, previously they, now only one of many major implementers of CPUs, can't get their own security extensions working right. And I also wonder, how is it possible that customers are not reimbursed, right? Why do customers not get, I mean, except the answer is money, right? It's all about the freaking money. But if you buy a car with security faults, you would get some recall and stuff, right? Why are those major features of CPUs not recalled? Like, yeah, money and stuff. But then also Intel and AMD and NVIDIA and ARM and stuff, they, in my opinion, need to work better and develop their stuff top-notch, rocket science kind of secure, right? Maybe this stuff, this is also the problem of x86, why I applaud the advent of RISC-V. Stuff needs to be worked out better in a community, international standardization process community like RISC-V, and really think about the stuff, even if it takes a year or two, and not like YOLO stuff on a conference table of like, hey, let's make some marketing slides of this stuff is top-notch secure. I'm not even saying it's easy, right? I fully understand working in the industry for 20 years. I understand it's freaking hard, but then maybe CPU vendors should not alone in their garage or basement, aka their conference table with some coffee, cheers, make up some allegedly marketing secure enclave extensions, and then later find out, oops, it wasn't really secure, and it's like, yeah, we also don't warrant warranty because it's too expensive and stuff, and just remove the feature, right? And Intel, this is a recurring theme, not only with previous Pentium bugs, but even recently with a transactional synchronization extension, TSX, a similar fate, right? On paper, this extensions also read actually quite nice. TSX, so-called transactional synchronization extension, as I said, really interesting, adds hardware transactional memory. That already sounds interesting and good. For speeding up the execution of multi-threaded software through log elision. According to different benchmarks, TSX provided about, at times when the stars align right, 40% faster application-specific workloads and 4 to 5 times more database transactions per second. And this stuff reads super dry, but lo and behold, the stuff is even used in your favorite PS3 emulator, PCS3. And they're similar to the BluRay player. This was Cyberlink's, what is the name of Power BluRay or so? Whatever the, doesn't matter. Product name was, doesn't matter. Something, Power DVD, yeah. 2022, you play Blu-ray and Power DVD. Find the joke, but similar to here in the FAQ of upgrading your CPU, right? Because it is, of course, also known that emulating the mighty processing power of a PS3, also this way, right, for the logo and stuff, relatively powerful cell architecture, right? And emulating that in software is actually relatively CPU intensive. So all acceleration help you can find there certainly helps. And the fine developers of RPCS3 actually implemented using the TSX extension exactly for that, for avoiding locking memory. And basically what this does is, like, especially here in the context of the PS3 of emulating all the cell processing elements. So what TSX allows for is marking memory regions for transaction. Where was it? Optimistic execution of transactional code regions. So with these new instructions, hardware log elision allows, with those instruction prefixes of X acquire and X release, allow execution of code. Where was it even written? Here was some nice summary of that. Basically allows execution of code and then being aborted. Where was this mentioned? So basically you can speculatively run code, also speculatively already sounds good, right? Wait, this is probably a role. Where was this mentioned? Yeah, whatsoever. But so basically, what this was supposed to do is rolling back these transactions if, like basically marking memory, and then if another thread of execution is also accessing this memory, rolling back this, and basically for the case of no conflicts in memory access, avoiding locks. Maybe we find this here. But as this summary also mentioned, of course, in 2016 already a side channel timing attack was found abusing the way TSX handles transactional faults, page faults in order to break kernel address space randomization on major operating systems. And in 2021, Intel released a microcode update disabling TSX feature on CPUs generations from Skylake and Coffee Lake as a mitigation for discovered security issues. And again, right, similar or just identical to SGX here in TSX, instead of having a warranty, having a recall like famous car analogies, Intel sold something half-baked, half-working. As per usual with their "we are Intel, we got that," not. Shipping stuff half-baked to the customers without their due diligence of formal verifying this, of really thinking this through. Of course, I don't have any insider knowledge there, whether the Intel engineers knew at the time already that the stuff is fishy, that they were forced to rush it to market, or if, to the best of their knowledge, they did not know that. The stuff is, of course, so complex. The question is, of course, should we Intel, AMD, and everyone else with RISC-V, should we, as humans, implement extensions as complex that they do not work proper? Or should we rather work together with open instruction set architectures like RISC-V and formally verify this stuff and create extensions that actually freaking work at the end? But in my opinion, just as I said before, it should not be that major CPU manufacturers sell silicon to the masses and later it's like, yeah, YOLO, whatever, this stuff doesn't really work like advertised. And that hardware companies or even software companies, but in this case, of course, hardware companies, or even mixed, I mean, there is some driver support glue software, should not get away with just disabling stuff, right? They sold the stuff to the users and just take it away, right? It's like, yeah, YOLO, we messed up, doesn't freaking work, we just deprecate it and disable it, right? The crazy stuff is maybe the software license agreements, although if you install Windows, you of course don't sign a software license agreement with Intel though. And you also usually don't read fine print. I wonder if you order a boxed version of a CPU, maybe it comes with a fine print of like, yeah, preliminary. The crazy stuff is also often specifications already read in the subtitle with preliminary information, and Intel reserves the rights to change and update the specification at any point in time, including probably removing whole sections about TSX and SGX. Anyway, that is the quick video today. I hope you learned something. If you're interested in other complex CISC or RISC complex or reduced instructions and architectures, Intel's extensions, or how this compares with MIPS, Spark, RISC-V, or other such stuff, I have previous live streams and videos there in the archive. And otherwise, let's take a quick look at the comments. I hope we explained everything in the meantime. Remember correctly, remove the capability due to security reasons related to branch execution. Yeah, so they removed it for the stuff is not secure enough. But yeah, yeah, multiple things as I laid out. Should the user be more free to choose whether to use something half working or 90, maybe it's even like, maybe you could even say it's 99% working, just the last percent, the last secure percent is always the most difficult. Recurring phrase here. Similar to our own software, right? So the first 99% are easy and the last 1% take 99% of the time, aka making the stuff actually really freaking secure. But for the user, it has only negative consequences, right? The user could not give even less sense of an F to using this. For the user, it is only taking features away, right? And I mean, the crazy thing is it only matters for the content creation in this industry with their digital rights management for the user and protecting the children and stuff. For the user, it's only removal of features. The user loses ability. They purchased Blu-rays, Ultra HD 4K Blu-rays. The user purchased the Intel CPU and Windows and potentially Cyberlink's DVD. What was it? Power DVD. So the user just loses features they paid for. And so two questions, as I said, should hardware vendors even allowed to remove after the sale, years later, remove features because only years later they disclose they didn't work as advertised? Should the users be compensated? I mean, probably class action lawsuit, right? And last but not least, should the user have more choice as the feature is already in the CPU and 99% working? Should the user have more of a choice than it's like, hey, don't update the software, right? Just stay on, make sure you don't update the BIOS, make sure you also, I mean, this is also not updating Windows, right? Because not even updating the BIOS is enough because Windows also, is my understanding, updates the microcode on boot, loading the latest microcode. So probably you would need to actively keep Windows from updating some microcode database or disabling the microcode loading service at boot. So should there be, maybe there should at least be a more prominently visible BIOS switch of enabling, disabling SGX to give the user who actually paid for this, even though like NSA, like some users who really need the security, like data center, like think Amazon Web Services or Google or similar such services or Microsoft Azure. Maybe some even wanted to use this feature for actual real work and not like some toy feature that is Power DVD. And although there you of course have also some BIOS control, but should there be a more visible control for the user to actively keep this enabled for their not 100%ly, but at least usable use case of playing back Ultra HD 4K videos, or for example in the case of RPCS3, TSX to keep using their fancy P3 emulator. Anyway, this extension, especially, I mean, both extensions sound quite useful. I wonder if they could ever be implemented securely in other silicon. The problem is, of course, last but not least, software patents, right? For sure, Intel patented the heck out of that to prevent AMD from implementing that, I would assume. And thus also the new open hardware community and companies like Sci-Fi, Hi5 with RISC-V or other community implementers or startups. So that is the problem, right? A recurring reminder that software patents, not really a cool thing. So even if you wanted to implement such secure and transactional memory performance increasing features here, implementing this in RISC-V, also there's even experimental support for QEMU. I didn't even know that, I learned something new here. And yeah, this is the problem with software patents, right? So that is then even more of a challenge if you wanted to implement something similar for RISC-V. You would definitely, from my experience, double and triple the amount of work to read through Intel's patents to make sure that you actively need to implement something different enough not to be in violation there of Intel's patents, right? That is, last but not least, a very not cool situation with this software patent. So, recurring reminder that my stance to software patents, it's like, yeah, it shouldn't, mathematical stuff should not be, software should not be patentable. Or actually, this is hardware, right? This is actually a little bit different, but yeah. And even if you would argue patents are in some ways helping companies making money with their broken half-assed implementation, I would argue this stuff should not be patent protected for 20 or so years. Maybe something reasonable would be 5. In my opinion, I mean, the crazy thing is even Intel abandons that actively, right? So instead of leaving a minefield, a patent minefield for other alternative implementers to implement something similar but working with RISC-V, the protection period should maybe only be 5 or 7 years or so, because then at this point we as a community could implement stuff like that for RISC-V without having to actively work around Intel's patents in this area. But anyway, that's it for this video. I hope you learned something. Even with a normal user, right, with a state of PC, even your BluRay playback there, or PS3 and similar such emulation fun. Don't forget to select subscribe for similar such videos, and leave in the comments below what you think about the situation, Intel's removing features, and the state of x86 and very complex instruction set architecture. One last comment is can't patch the hardware, just the software, but on the other have some performance can be lost. I mean, they can somewhat patch the hardware, right, with the microcode update. There were microcode updates here, and they at times can fix some stuff, right? So for a lot of the Spectre and Melter mitigations, they have updated the microcode to even at, I think at times even at new CPU ID, CPU ID signaled corrections and indications that the CPU now is honoring some new security bits. So they can update a lot. Of course I'm aware they cannot change everything, but last but not least, as I said earlier, vendors should not be allowed to remove features for free. And if they can't fix it reasonably in a microcode update, last but not least, I would actually argue they would need to be forced to provide a new CPU, right? It's not our users' problem that Intel sold us something not really working as advertised. And then they should just, well, first of all, provide a working sample. And if they can't for the old version, provide a new one. It's not the users and our problem that Intel shipped something not really working. Or compensate them with some, let's say, $50 or something of, okay, the whole CPU is not defect, but this one feature, so you in a class action lawsuit maybe get some $30 or something, like other OS removal of the PS3, right? And last but not least, then I fully understand this is difficult and hard work and stuff. Then the vendors like Intel and AMD and ARM and NVIDIA and so on, they need to validate the stuff longer, right? They shouldn't, it's not our fault that they rushed this potentially to market with knowing or not knowing that this is broken, but they just need to double and triple their formal verification infrastructure. And yeah, sure, hardware business is difficult, but they have chosen to do so. They were one leading company, previously leading company in that field. And if they want to stay there, not only patent stuff and create a minefield for others not to follow, but also do their due diligence and actually formally verify and properly test and verify this stuff, quality or QA their stuff, to sell working stuff, fully in spec stuff to the users and not take stuff away. Yeah, Dr. Schubert said just that what I ironically just said of Sony removing other OS from the P3 here, similar such stuff. Anyway, so that's it for this video. I hope you learned something and see you soon for all the next fun stuff to come.